Okay, so we are on to lesson 17. I'm going to go for the proof-based questions first. So we'll start with question 10. Are triangles ABC and DEF similar? Why? Select yes or no and all appropriate reasons. Okay, so for polygons to be similar, they have to have corresponding angles be congruent and corresponding sides be proportional. In order for them to be proportional, that means that they have the same ratio between corresponding sides, which is our scale factor. So the first thing that's the easiest to check, since it's labeled, is are the corresponding angles congruent? So what is a corresponding angle? The angles that match up. So it is given that triangle A in ABC, A is our first vertex, and in the second triangle, D is our first one. So I'm going to compare angle A, which is 106, and its corresponding angle D needs to be 106 to be similar, which it is. The next corresponding is listed as B. That is our second one. And in the second triangle, E is what's listed. So B and E are corresponding, and they need to be the same. So B is 33 degrees and E is 33 degrees. They are congruent. Our last corresponding is the third listed. And the third listed is C, and the third in our second triangle listed is F. So C is 41 degrees, and F is 41 degrees. So since all of our angles are congruent, we're part way finished with checking for similarity. The next way we need to check is corresponding sides being proportional. So I need to check corresponding sides, and how I know that? They are corresponding sides. They are connecting the same vertex. They are connecting corresponding vertexes. So side length AB is connecting the first vertex to the second vertex. So its corresponding side would be connecting the first vertex to the second vertex in our second image. So side length DE is our corresponding side. Another way to tell is they're listed AB and DE. So AB's scale factor, the scale factor for our corresponding sides, we would compare AB to DE. The next one is going to be connecting our second vertex, the side connecting our second vertex to our third vertex, which is BC. And its corresponding side is also going to be connecting the second vertex to the third vertex. So that's going to be EF. So EF. And you notice it's listed right here, B to C and E to F. And then our last scale factor that we need to check is going to be connecting our third vertex to our first vertex in both triangles. So that's going to be C to A in our original, divided by F to D. Since they're not specifying that one's an image and one's a pre-image, we can choose which is considered our original picture, and that will be the one we referenced. So I used my original picture to be triangle ABC, and if you notice, all of ABC's lengths are in the numerator position. So it needs to be set up that way in all of our scale factors. So now we're going to use our substitution property of equality to find our scale factors for corresponding sides. And so AB's length is 33 units. DE's length is 22. BC by substitution is 48. And EF by substitution is 32. CA by substitution equals 27 because it's at the length, and FD length is 18. So now we need to use our calculator and simplify or reduce. 33 divided by 22 is going to give us 1.5. $48 divided by 32 is going to give us 1.5. 27 divided by 18 is also 1.5. Since our scale factors are all the same, the corresponding sides are proportional. So yes, because corresponding angles are congruent and the corresponding sides are proportional. So question 9 is similar to question 10. So we'll move on to question 8. Triangles ABC and DEF are similar. The length of DE equals 2, the length of EF equals 2.24, and the length of DF equals 2.24, while the length of BC equals 3.33, and the length of AC equals 3. What is the length of segment AB? The length of segment AB is blank. Enter the value that correctly fills in the blank in the previous sentence. Okay, the key here is similar. They are defined to be similar. So we know that corresponding angles are congruent, and we know that corresponding sides are proportional. So now we have to identify what are the corresponding sides. So triangle ABC and DEF, it is listed in that order. So I always circle the first two in each. So AB and DE are AB and DE are corresponding sides. Then the next one to tell would be the next group of two, or order of two. So then BC and EF, B to C and E to F are corresponding part, and there's only one leg left, therefore AC and DF are corresponding sides. So they are asking for us, what is the length of AB? Which is right here. So we need to set up a ratio. So let's set up our scale factor for the sides. So our corresponding side for AB, so I would have AB compared to DE. K is going to equal CB compared to EF. And K is also going to be FD to AC. Oops, that's for my second triangle, so I need to make sure that I'm using AB and CD are all from the largest triangle, so I need to make sure when I'm setting up my last one that AC is in the numerator. So AC compared to DS. So now by substitution, we're going to have this length. We're going to substitute their length. So AB is equal, I labeled it as X. I don't know that length. DE's length is 2. CB by substitution, I know they listed it as BC. CB and BC are the same side length. It's just saying, like, for example, from my house to the library would still be the same distance from the library to my house. So it's still the same distance. So CB is equal to 3.33, and its corresponding side is EF, which is 2.24. AC is 3 divided by, and DF is 2.24. So now X divided by 2 is X divided by 2. I'm not sure what that simplifies down to. 3.33 divided by 2.24, since they are both numbers, I can enter them into my calculator, which comes out to be 1.4866 with some remaining decimals. And then three divided by 2.24 is equal to, and right here I believe that they made a mistake. I believe AC needs to be 3.33 in order to have our same proportions. So 3.33 divided by 2.24, that's 1.48. 6 and some change. And so then, since our scale factor has to be the same for every single side, then we can use our transitive property, and this is because k equals x over 2 and k equals 1.486. So k equals x divided by 2 and k equals 1.4866. By our transitive property, that means we can cut out this middleman, our linking guy, and say x divided by 2 is equal to 1.4866. And in order to solve for x. Since I'm dividing by 2, I would use our multiplication property of equality and multiply by the reciprocal of 1/2, which is 2. So 2 times x divided by 2 is 2x divided by 2. This is going to equal 1.4866 times 2 is 2.9732. 2 divided by 2 is 1. So 1x equals 2.9732. And since these are rounded to the nearest hundredth, I'm going to round this to the nearest hundredth, so it's 2.97. Since 3 is less than 5, it would not round up that 7 up. So it would be 2.97. Now I'm looking at this and I am feeling like there is possibly an error occurring here because I know that I'm looking at triangle DEF right here. You notice this is 2.24 and this length is 2.24. They are the same length. That means that this is an isosceles triangle. And if these triangles are similar, then its corresponding triangle should have two side lengths that are similar, congruent as well. So if I think there's an error here. So I will have someone look into it. But our corresponding side for AB was DE, which is and then our corresponding side was B to C, and the other one is E to F. So these two, this one was congruent to DF, and DF is corresponding to AC. So then, if you look here, these two lengths should be the same because we had an isosceles triangle to right here, and this one has to be an isosceles triangle in order for it to be similar. So AC's length needs to be 3.33. That's the error. And so just note that in this diagram that AC is actually 3.33, and that's how I was able to set it up. So our answer is 2.97. And again, I will have someone look at it so that they can take care of it, and hopefully it's fixed before you see this question. And so your piece of advice from the Little Book of Calm by Paul Wilson is to massage your eyebrows. You do this intuitively when under pressure. Now you can do it consciously. Work the relaxing acupressure points around the forehead by massaging your eyebrows in an outwards direction. So there's your tip from Paul Wilson's Little Book of Calm.